I'll be talking about sharding in CouchDB. My name is Liv, or Olivia. I work at Neighbourhoodie, and I do all kinds of stuff, but I do a lot of CouchDB stuff. And recently I've had the opportunity to kind of have myself be plunged into a deep dive on sharding in CouchDB for some of the work that we do here. So I decided it might be a good idea to share some of those experiences, give a little bit of an introduction to sharding, tell you a little bit about what it is, tell you a little bit about what kind of databases actually do sharding outside of CouchDB, how you can use sharding. This is going to be a quick overview more than a really in-depth thing because I don't have that much time, but I'll try to do my best. And also just a notification, just a note, if you're commenting in the channel, I will have a look at that after the talk. So I'll answer any questions after the talk because I only have one screen right now. So let's get started. Maybe some of you are a little bit confused over sharding. Until I learned what it was, I was certainly always a little bit intimidated. Sharding sounds like such an arcane term. But we'll start from the top. So each database provides a bunch of methods as your load increases to scale with that load. So you can handle more and more traffic, more and more reads, more and more writes. There are broadly two categories of handling this load. One is vertical scaling, which usually means throwing more resources at whichever machine is running your database. So for example, if you're running on AWS, upgrading to the next biggest, what would it be, like next biggest EC2 machine size or whatever, or giving the machine a faster network connection, or anything along those lines. The other way you can go is to go for horizontal scaling, which usually means taking the data you have and splitting it into sort of logical partitions, logical, parts that you can then distribute, maybe even across multiple nodes, which leads to a number of benefits. One being, in some instances, shorter access paths. If you split shards, shards, I'm getting ahead of myself. If you split these across, for example, document IDs, logically, then you can get much faster read and write time, since the database basically has a very short path to the document itself. The other thing, and this is, I think, one of the main benefits for a lot of people, is data loss resilience. So you can more easily duplicate smaller partitions of data, or shards, we should now call them, and distribute them across nodes. So in CouchDB, for example, if you have a cluster of a couple of nodes, if one node is dead, then you're not losing any of the data if you have enough shard replicas. And you obviously also get all of the other benefits that in CouchDB come with having a cluster, such as geographical reliability, for example. And, well, I'm just going to leave it at that. My mind's blanking now. Maybe a quick aside, there are some other databases that shard. I'll be categorizing them broadly into relational databases and NoSQL databases. As for relational databases, it's usually a little bit harder to shard because the data can be very closely coupled, which is really in the name, relational databases. A notable exception to this is OracleDB, which is about the only SQL database I've found that has native sharding capabilities. The other ones, like Postgres, MySQL, Microsoft SQL, all have some sort of third-party sharding extension. As for NoSQL databases, MongoDB does shard, but it doesn't do it automatically. You have to enable it. And also, confusingly, MongoDB kind of conflates the terms sharding and setting up a cluster, which I personally find a little bit confusing. So in MongoDB, as far as I know, when you're talking about sharding, you're always talking about setting up a cluster. nothing else is really noteworthy. So CouchDB kind of remains an outsider in the way that it is one of the few database systems that shards automatically. When I was doing research for this, I would have thought there were a couple more, and there are some very niche ones, but CouchDB really is one of the only ones that does it just automatically. So like even on the single node, as the new default for shards is 2 in 3.0, so there will always be, even on a single node, there will always be 2 shards, even if you don't do anything. So it's the default, it does it automatically. It's quite interesting, I think, to know. Now that we know that, let's talk about how sharding works. So there are 2 important values to keep in mind. One is Q, which is the number of shards for each database. So sharding can be controlled per database. It's not a whole overarching instance configuration. You can have one database be 3 shards, one be 2, and one be 1, for example. And that parameter is known as Q. The other parameter is N, which is the number of shard replicas. So this goes back to what I was talking about before, which is how many replicas of these shards you want to distribute across your cluster. Naturally, this really only makes sense in a cluster. So for a single node, the N is by default 1, because it doesn't really make sense. It would just be wasting disk space. But for a cluster, I believe the default is 3. So for example, if you have Q equals 2, N equals 3, which is the default in the cluster, you would have 6 shards in total per database. In CouchDB, shard IDs are hashed from the document IDs using the CIC32 hash, which achieves a relatively uniform hash distribution. That's just me reading what's written there. What this means is that you don't need to worry about your ID distribution, because CouchDB hashes your document IDs before adding them to a shard, which means that no shard, or very rarely will shards be much bigger than one another. So usually shards are fairly evenly balanced unless you have a lot of deleted documents or conflicts or something like that. And here's an example, 2 shards per database. So one will be this hexadecimal range, one will be the other. So you can see it's completely evenly spread by the hashed ID. One big benefit that you get from sharding in CouchDB is that since you have multiple partitions or multiple parts of your data, you can process stuff like view indexes more efficiently and in parallel. So CouchDB will by default spawn a Q number of CouchJS processes, which is used for indexing views, which can massively increase performance if you're really having problems with that. Obviously, this only works if you have multiple CPU cores, but it is a very important performance consideration. All right, let's quickly have a look at some cool stuff you can do with shards. The most basic thing you can do is just to HTTP get, send an HTTP GET request to your database. Have a look at the cluster key, which will tell you the value of Q, of N, and of W and R, which are read and write chromes, which I'm not going to go into because, frankly, that's kind of a different topic that has more to do with clusters. I mean, it's related, but it would be blowing the scope. You can also find out where exactly shard replicas are placed in your cluster by calling the database name /_shards endpoint. So for example, this will tell me that the first shard here with this shard range, 000, etc. to 7FFF, etc. is stored on node 1, 2, and 3, which is how it should be. But for example, if you had 4 nodes and n equals 3, it might be 1, 2, 4, for example. One cool thing you can do is you can actually split a shards into 2 smaller shards. So this is done by the reshard endpoint. I'm not going to read out all of this stuff. Basically, we're telling it split this shard with this range on this database. What you need to keep in mind when doing this is that Q will now be 3, and you will have 2 smaller shards and 1 bigger one, which can lead to a weird performance degradement, or not optimal performance at least. So what you'll ideally want to do is you'll want to split the other larger shard into 2 smaller shards as well. So you have Q equals 4. Yeah, just something to keep in mind. As for reducing your Q value, this is not really possible in CouchDB itself right now. The reshard endpoints only support splitting shards up, but not down. But at Neighbourhoodie, we've kind of developed a little Node.js CLI tool that can do it for you. It's a very simple procedure that you can also do manually. It basically consists of creating a new database, a replicate database with the new Q value, replicating your data there, then destroying the original source DB, recreating it with the new Q value as well, and then replicating the data back. This will incur some downtime. There's some other ways you can do it without not losing downtime, mainly just by updating your application code to point towards the replicate database. But I won't go too far into it. I'm not actually sure if it might head to CouchDB in the future. I don't know what the development plans are, but there are some considerations I could think of when doing it in CouchDB itself, but I won't linger too long on it. With that being said, all that said, some stuff I've learned that you should consider in production. Shard management is generally, while the reshard endpoint makes it kind of easy to increase queue size, it can be a bit tricky. It can sometimes be a bit finicky. You should ideally, at the very start, know how big your database will get in the future. And you should decide on, okay, this is going to be my initial Q value. If my database grows like this and this, my Q value will increase to this and this. Going to a really huge Q value usually doesn't give you a big benefit, since it also just drastically increases the resources consumed. So you want to be sure that you kind of know which Q value you'll be going for when you start. This is what I've said before. Split shards quadratically, so from 2 to 4, 8 to 16, so you ensure you have evenly sized shards. And if you have under 10 million documents, or you just store a lot of like attachment data, for example, I think it's upwards of like, what was it, like a couple of gigabytes. If you're below that, then you use a Q value of 1 or the default of 2 in CouchDB 3.x. It's generally more advisable to start small because you can always split upwards more easily than you can go down in shard size, shard amount. There we go. And finally, well, not finally, but n should always be at least the number of nodes in your cluster. I feel like that just makes sense. It's kind of self-explanatory. But lastly, shards are a cool tool, but if you're not correctly using CouchDB, if you're not reasoning about your document design all that well, then shards won't really help you mitigate that. I mean, maybe temporarily, but at that point you have bigger issues. So always the most important part in CouchDB that I found is get a consistent and like well scalable document model. CouchDB can do a lot of things, but it can't do everything. Some significant part of it is still user fault if you have bad performance. I think that's about it. So thank you, everyone. Here's a link to my slides. Any questions about sharding or best practices, anything like that? Other than using more threads, is there a downside with using a large Q value? Off the top of my head, I would say yes. If you're using a large Q value when you don't clearly need it, when it's not especially performance critical, you are, like CouchDB in general is very hungry for resources. And the more stuff you need it to do, the more resources it will happily consume. So using a large Q value will really just, it might even slow down the rest of the database. Or if, God forbid, you have other stuff running on the same machine, slow down the rest of the other stuff running on the machine. That is off the top of my head. I'm not sure if anyone has a specific downside that comes with that. Any interaction of partition and sharding setting we should be aware of? generally, I haven't like looked into partitioning a lot. As far as I understand it, is like partitions order the partition data into one shard, right? So depending on how much partitions, or like how many docs you have in a partition and how many shards you have, it seems to me to be possible that you might not fit all of the data on a partition on a single shard if you really have a lot of shards. Okay, or CouchDB doesn't even allow you to go to have a partition fit on multiple shards apparently. So that's good to know. Yeah, so if you have like a really big partition, I think you're using it wrong. And with that, I'll be stopping my stream. Thank you, everyone.